Unit 1B, Lesson 1. This will align with Lessons 2.6, 3.3, and 5.1 in your textbook. The main standard we're going to work with is prove theorems about lines and angles. These theorems will include vertical angles are congruent. When a transversal crosses parallel lines, alternate interior angles are congruent and corresponding angles are congruent. Points on a perpendicular bisector of a line segment are exactly those equidistant from the segment's endpoints. In this lesson, there's going to be a lot of new information. Before we get to actual proofs, there's a few theorems and postulates we need to discuss. The first one is postulate 12, the linear pair postulate. This says if two angles form a linear pair, then they are supplementary. When you think of linear pair, think of line. It's two angles that form a line. So if we look at these two angles here, they form a straight line, angle 1 plus angle 2. The measure of a straight line is 180 degrees. So these two angles are supplementary. Okay, so supplementary means two angles that add up to 180 degrees. A linear pair is two adjacent angles that form a line. Next, we're going to discuss vertical angles. If you look at the picture down below, we have two lines that are intersecting to form four different angles. Okay, opposite angles, for instance, 1 and 3, or 2 and 4, those are each pairs of vertical angles. The thing to remember about vertical angles is that they are always congruent. And like I said before, angle 1 and angle 3 would be one pair of vertical angles. Angle 2 and angle 4 are another pair of vertical angles. So looking at these pictures, 2 and 4, the value of those angles, they would be congruent. 1 and 3 would be congruent as well. The next theorem is called the congruent supplements theorem. This says if two angles are supplements of the same angle, or of congruent angles, then the two angles are congruent. For example, if angle 1 and angle 3 are supplements, and angle 2 and angle 3 are supplements, then that implies that angle 1 must be congruent to angle 2. This is a form of the transitive property. Okay, very similar to the transitive property. That property says if A equals B and B equals C, then A equals C. You'll realize throughout geometry there's going to be many theorems and postulates that use a form of this transitive property. Now we're going to go through our first proof of the year. And this is going to be a proof to show why vertical angles are always congruent. When we're talking about proofs, the most common type of proof we're going to go through is a two-column proof, which I'll talk about in a little bit. When we're completing a proof, there's two pieces of information we're always going to be provided with. One is called the given. That's information we can assume to be true. It's what we're starting with. And the other is what we're trying to prove. So the given is the information we're starting with. The prove, that statement is what we're ending with. What we're trying to do in the proof is complete everything in between. Okay? So now we're going to look down below. Here's our setup for our two-column proof. On the left side, we're going to have our statements. And on the right side, we're going to have our reasons, kind of our justification. These are going to be our theorems and postulates that verify why those steps are true. So step 1, this is our information from above, our given. We know angle 1 and angle 4 are a linear pair. I just condensed that right here. Angle 4 and angle 3 are a linear pair. I condensed that right here. So the reason for that is very straightforward. That is just our given. That's the information we were provided with at the beginning of the proof. If you look over here, before we talk about step 2, if you look at the last step, that is our proof. Okay, that's what we're trying to end with. So to practice with these proofs, you know you're always going to start with our given and always end with the last statement. And what you need to do is fill everything in between. Fill in the gaps. Okay, so going back to step 1 now. Angle 1 and angle 4 are a linear pair. Angle 4 and angle 3 form a linear pair. Well, from that information, I know if two angles form a linear pair, then those two angles must be supplementary. So for step number 2, angle 1 and angle 4 are supplements. Angle 4 and angle 3 are supplements. And my reason for that is one of those postulates we just talked about, the linear pair postulate. I'm just going to condense that. The linear pair postulate, if we know they form a linear pair, then those two angles must be supplementary. Now we're going to go from step 2 to step 3. Step 3 is our last statement. We know angle 1 is congruent to angle 3, and that was the congruent supplements theorem. And as we start going through these proofs, you're going to realize that you can start to condense some of these terminologies, these terms, for the theorems and postulates. So the congruent supplements theorem, we know that if two angles are supplementary to the same angle, then they must be congruent to each other. So this is a proof that shows why vertical angles, angle 1 and angle 3, are always going to be congruent to each other. Before we go into our second proof, there's a few more pieces of information we need to discuss. The first being a transversal. A transversal is a line that intersects two or more coplanar lines at different points. Okay, so down below we have our two lines, and then we have a separate line that intersects those two lines at different points. This line is called our transversal. And the reason a transversal is important is, if you look at this picture, we have 8 different angles that are formed by that transversal intersecting those two other lines. There are special names that we're going to use for each of those angle pairs. So there's 4 main types of angles we're going to discuss that are formed by a transversal. The first one is corresponding angles. When you think of corresponding angles, you want to think of angles that are in a similar position. So examples are angle 1 and angle 5. If we look at angle 1 and angle 5, where these two intersections occur, both these angles are to the upper left. Angle 1 is at the top left, angle 5 is at the top left. They're in similar positions. 2 and 6 would also be a corresponding angle pair. 2 and 6, they're both up and to the right, up and to the right. So corresponding angles, think of angles that are in a similar position. The next angle pair we're going to discuss are alternate interior angles. Alternate means on opposite sides of the transversal. Interior means in between these two horizontal lines. So one pair of alternate interior angles would be 3 and 6. Angle 3 is to the left of the transversal. Angle 6 is to the right of the transversal. And they're both inside these two horizontal lines. So this would be one pair of alternate interior angles. 4 and 5 would be another pair of alternate interior angles. Down below to the left, we have consecutive interior angles. These are often referred to, another name for these, same side interior. So consecutive or same side means we're going to be on the same side of the transversal, and interior again means we're going to be inside these two horizontal lines. So 3 and 5 would be one pair of consecutive interior angles. 4 and 6 would be another pair of consecutive interior angles. The fourth angle pair, alternate exterior angles. So alternate, remember, means opposite sides of the transversal. Exterior, now we're going to be outside these two horizontal lines. So angle 1 and angle 8 would be a pair of alternate exterior angles. 2 and 7 would be the other pair of alternate exterior angles. There's some special information that occurs when the two lines that are cut by the transversal are parallel to each other. If the two lines are parallel and cut by a transversal, then corresponding angles are going to be congruent. Alternate interior angles are going to be congruent. Alternate exterior angles are going to be congruent. and consecutive or same side interior angles are going to be supplementary. So when we're working with these problems, many times these lines are going to be parallel to each other. How we know whether or not these lines are parallel to each other: one, they'll tell us they're parallel, or two, if we look at the picture in this example, we have these two arrows on the lines. This implies that these two lines are parallel to each other. So these corresponding angles are congruent. So in this case, if we are trying to solve for x, we could set up an algebraic equation where 2x minus 3 is equal to 65. Now we're going back to algebra 1. We could solve for x to solve this problem. Okay, so special pieces of information: corresponding angles, alternate interior, alternate exterior. If those two lines are parallel and cut by a transversal, all of those angles will be congruent. Consecutive interior angles will be supplementary. Now we're going to complete the second proof. This is going to be a proof showing why corresponding angles are always congruent. Okay. So our given information in this case is K is parallel to M. So K refers to line K, M refers to line M. These two vertical lines side by side, that implies they're parallel to each other. What we're trying to prove is that angle 1 is congruent to angle 5. If we look over here, angle 1 and angle 5, those are corresponding angles. They're in a similar position. Again, we're going to complete a 2-column proof. Statements on the left side are reasons, justification on the right side. First thing we're always going to write down, for the most part, is our given. So our reason for that is given, the information we're provided with. From step 1 to step 2, I say angle 1 and angle 4 form a linear pair. Well, if we go back to the picture and look, angle 1 and angle 4, two angles that are adjacent and form a straight line. So our reason for that is definition of a linear pair. Okay, if we look back at the definition for what a linear pair is, that is what angle 1 and angle 4 are, so they satisfy. That's our reason for that. From step 2 to step 3, this should be similar because we used it in the last proof. If two angles form a linear pair, then those two angles are supplementary. That was the linear pair postulate. Again, I'm going to condense most of these postulates, definitions, and theorems down. Now for step 4, I say angle 4 and angle 5 are supplements of each other. Well, if I look at angle 4 and angle 5, that's one of those special pairs of angles we just discussed. These two lines are parallel to each other. These are consecutive interior angles or same side interior angles. We know if these two lines are parallel, then consecutive interior angles are supplementary. So we can just write consecutive angles. We write consecutive interior angles. I know that's implying that you're referring to that theorem. So now if we combine steps 3 and 4, we have two angles, angle 1 and angle 5, that are both supplementary to angle 4. So for step 5, I'm going to say angle 1 is congruent to angle 5, and that was our congruent supplements theorem. So I used our symbol for congruent, our tilde with the two equal signs, supplements theorem. If we have two angles that are supplementary to the same angle, then those two angles must be congruent to each other. So we started with our given that those two lines were parallel, and we showed that an arbitrary corresponding angle pair was congruent to each other. So corresponding angles will always be congruent, and this was a proof that shows why that's always going to be true. These are the only two proofs I'm going to go through right now in this lesson. Make sure you come to class prepared to discuss any of the theorems, definitions, angle pairs, or how we approach these proofs. Okay, come to class prepared with questions ready to go. We'll go through a few other proofs together in class.